I guess I will just say everything I just said over again because it didn't have the video going. But we're going to talk about temperature right now. Nope, too far. Wait, maybe not too far. Oh yeah, I need to go further. Didn't go far enough. Here we go, temperature conversions. Okay. So this is where we are, right? Temperature conversions. All right. Let me get out the notes so I can see what you guys are looking at here, so I know which blanks you're filling in. All right. So the definition of temperature you're probably familiar with. Well, tell me what you think temperature is. When I say temperature, how would you define that? Okay. Well, that's the unit, right? But what were you going to say? Okay. How hot or cold something is. That's a pretty good definition. We're going to do a little better than that in chemistry. That's probably the one that you're familiar with, and that's actually the first definition that's on here. It's a measure of how hot or cold something is. I think that's almost word for word what you just said. So, good. Oh. It's on the notes. I thought that was a blank you had to fill in. Okay, all right. I believe you. Now, in chemistry, we're going to go a little bit further than that. We're going to say that temperature is the measure of the average kinetic energy of the particles. You guys remember talking about kinetic energy? Yeah. Versus potential energy? So what do I mean when I say kinetic energy?
I know potential energy.
Okay, what's potential energy?
Well, like, storage happening when it's stored up.
Okay, is that what you were going to say? Stored energy? Okay. So that's a good definition for potential energy, is maybe stored energy or energy that has the potential for movement. You're not supposed to use the word in the definition, so that's probably not good. But what about kinetic energy? It's unstored energy, okay. Energy being used. And when we talk about kinetic energy, we're really talking about the energy of movement, okay? So with kinetic energy, something is moving, all right? So basically, all I'm saying here, when I say we're measuring temperature as the average kinetic energy, we're measuring, on average, how fast are the particles moving, okay? And that's how we measure temperature. The faster they move, the harder they hit your skin, the more energy they transfer to you, and the warmer you feel, okay? The slower they move, the less hard they hit your skin, the less energy they transfer to your skin, and the colder you feel. The particles. Yeah. All right. So thermometers, that's typically the way that we measure temperature, okay? And I'll go through this part quick because you don't have any blanks here. But chemists typically use the SI base unit Kelvin. Now it says remember. I'm not sure that we actually have talked about that yet, okay? You're probably familiar with Fahrenheit and Celsius. In this class, we're going to use Kelvin quite a bit. Especially in this unit, we use them with gas laws. You need to be familiar with Kelvin, okay? So we'll talk a little bit more about that. There's some simple formulas for converting between these units. Well, I don't know about simple between Fahrenheit and Celsius. Does anybody know that conversion off the top of your head? Without looking at the notes? See, I shouldn't have said that because then automatically you look at the notes, right? Yeah, temperature from Celsius to Fahrenheit, it's tough, all right? Celsius to Kelvin's a lot easier. That's the good news. So here are the temperature conversions. I think they're on here. So to go from Celsius, to calculate Celsius when you have Fahrenheit, you take the Fahrenheit temperature minus 32, and then you multiply it by 5/9. Simple, right? Yeah. And then for Fahrenheit, you take the Celsius temperature times 9/5, and then you add 32. Okay? Now the order is very important there. That's why certain parts of this are in parentheses. You need to be careful when you're putting this in your calculator that you do it in exactly this order. All right? Do the subtraction first. Hit equals on your calculator, and then multiply by 5/9. Otherwise, you're going to come up with the wrong answer. I will give you this equation. Yeah. So you don't need to memorize this, but you do need to know how to use it. Okay? The Celsius Not as big a deal, but I would just to be on the safe side, I would multiply by 9/5, hit equals, and then add the 32. Okay. But the top one, I can tell you for sure, if you don't hit equals on this first step, you're going to get the answer wrong because your calculator automatically does multiplication before it does subtraction, right? That's how your calculator's set up. So if you don't tell it to do the subtraction first, it won't. Okay. Temperature can be converted using these simple formulas. Let's do an example of that. Okay, so Dave Murray, the weatherman from Fox 2 News, started out his weather forecast with the current temperature. Told us it was 21 degrees Celsius. I don't know why he would do that exactly, unless he's just wanting to show off how smart he is. Because usually weathermen report the temperature in Fahrenheit, right? But what temperature is this in degrees Fahrenheit is the question. Okay. So what we need to do here, we need to figure out the Fahrenheit temperature. So which of the formulas are we going to use? We use this bottom one right here, right? Okay? Because we already know the Celsius temperature, so we can plug that in. Yes, sir. Is that what you're getting? Okay. So, and that sounds about right. Okay. Yeah, well, we will. So we plug in the Celsius temperature of 21 degrees. So the Fahrenheit is going to be equal to the 21 degrees times 9/5. Yeah, what you have to do on that one is just multiply it by 9 and then divide by 5. Okay? That'll do the same thing. And then you add 32 to that. Okay? I hit equals a lot on my calculator, actually, because I don't trust it to do order of operations, right? Okay, so to the right number of sig figs, this would be?
7.
Yeah, 7. Yeah, that's tricky, isn't it? 70 point degrees. Okay, then we've got our 2 sig figs there. All right? So that's not too hard, right? You just plug it into the formula. Okay? All right, another example here. The temperature in Celsius of 93 degrees Fahrenheit. Okay, so now we need to look at the other one because now we have the Fahrenheit. We're trying to figure out the Celsius. So the formula on this one, go back to it for a second. We take the Fahrenheit minus 32. You have to do that part first, and then you multiply by 5/9. Okay? So we've got 93 minus 32. This is degrees Celsius. Times 5/9. Okay? So when you do that, let's see, actually just 34, right? For the correct number of sig figs, 34 degrees Celsius. I don't know why I circled the other one and boxed that one. Yeah, sorry. So that makes sense, though, right? I mean, you're just plugging into the formulas. You need to make sure you use the correct one in the correct situation. But that shouldn't. I don't think that's going to give you too much trouble. And if you thought that was easy, wait till you see the Celsius to Kelvin conversion.
Easier?
It's even easier. So Kelvin, we need to talk about Kelvin just a little bit here, okay? Kelvin is the unit that chemists use for temperature, and there's a reason for that. And I'm not sure if it's on here. Let me see. Yep, it is. So I'm not going to give it away yet. Based on the concept of absolute zero. You've never heard of absolute zero before? Okay. In theory, that is the temperature at which particles stop moving. Okay. In other words, the temperature at which the minimum average kinetic energies occur. Well, what's the minimum? It's like the smallest possible, and the smallest possible kinetic energy would probably be 0 if it's not moving, right? Okay, yeah. Let's not talk about that. They have discovered recently that they can create negative Kelvin temperatures, and that's just kind of blows my mind a little bit. So. All right. So at this temperature, all atoms stop moving. All right? It's all right. Thanks for the cans. You didn't hear me. So at absolute zero, there is no movement whatsoever. Now, we've never gotten to absolute zero before, but apparently we can get less than absolute zero, which is actually more than absolute zero. It's just negative Kelvin. So it's very confusing. Well, there's some interesting implications that I don't completely understand yet. So, I mean, this is kind of a new thing. I think it happened last year that they were able to actually do this. So, I don't know what all the implications are necessarily. All right. Absolute zero, it says it can only be reached in lab settings. That's not entirely true, okay? We can't reach absolute zero even in lab settings, but we can get very, 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 very close, okay? And at very, very, very low temperatures, we can do some interesting tests because the molecules really slow down for us. And so we can get a better look at them and see kind of what they're doing, okay? But that can only happen in a lab setting. And you go into an environment that's almost 0 Kelvin, you're instantly dead, okay? Yeah, so you don't want to be in that environment. Space is essentially 0 Kelvin where there's no particles because it's going to have the same effect on you, okay? If you take off your space helmet, you would explode. Yeah. Yeah, well, not implode because, you know, there's no pressure on the outside. You've got pressure on the inside. I would imagine it would be very fast, if not right away. I don't know. Okay. Yes, it's very cold. I don't know. I've never exploded before. How do I know what that feels like? Yeah. All right. So here's the conversions. And again, this is super, super easy, right? All you have to do is go from Celsius to Kelvin. I said that backwards. To go from Kelvin to Celsius, you need to subtract 273. To go from Celsius to Kelvin, you need to add 273. Now, the hard part on this is remembering, do I subtract, do I add, okay? And this one I'm actually going to ask you to remember, okay? You will get the Fahrenheit to Celsius conversion because, for one, we don't use that very much in science class. We use the Celsius to Kelvin conversion all the time with the gas law, so I want you to know that one, okay? But the hard part is remembering, oh, do I add 273 or do I subtract 273, all right? Here's how you're going to figure that out. There are no negative Kelvin temperatures, right? You know, I just kind of said that there are, but there really aren't for the purpose of this class, okay? The coldest you can get is 0 Kelvin, all right? So that means that if you get to 0 Kelvin, that's actually negative 273 degrees Celsius, right? And maybe I should give you some reference points. Maybe that would be helpful here, okay? Because we're not as familiar with Celsius as we are with Fahrenheit, all right? Anybody know what the freezing point of water is in Celsius?
0.
It's 0, okay? So 0 degrees Celsius is the freezing point of water. What's the boiling point of water?
273.
Now, actually, this is nice and easy here. That's why Celsius is, that's why I like it better, because you can just remember 0 and 100, right? So water freezes at 0, it boils at 100. That can't be a coincidence, can it? Now, the Celsius scale was actually set up with those two things as the reference point, okay? So they said, all right, we're going to make 0 the freezing point of water, we're going to make 100 the boiling point of water, and then we'll figure out the scale in between, all right? So that's why it is that way. Now, just to give you a couple other reference points you might not be as familiar with, does anybody know approximately room temperature in Celsius? Somewhere in the 20 to 22 range, somewhere around there. So about 20 degrees Celsius we would say is room temperature, okay? Anybody know what the average human body temperature is in Celsius? Okay, that's Fahrenheit. 98.6 is Fahrenheit. What about in Celsius? Okay, pretty close. It's about 37 degrees Celsius is the human body temperature, which is pretty close to 100 Fahrenheit, right? So right around there. Okay, so that gives you maybe some reference points for Celsius. All right, so now knowing that 0 is the freezing point of water, we can get colder than that, can't we? Can we get colder than 0 degrees Celsius? Can we get colder than the freezing point of water? Sure, that happens outside every winter, right? Okay, it gets colder than the freezing point of water. That's why we get ice on the roads. That's why we get snow and all that. Okay? What? Ice gets colder than the freezing point of water, absolutely. Yeah, you can cool ice down to, you know, negative 273 really, or close to it. All right. So the coldest you can get something in Celsius is negative 273. The coldest you can get something in Kelvin is 0. So which one of these temperature scales should always have the higher number? Kelvin should always have the higher number, right? Because you've got to get out of the negatives before you can get even into the positives here. I don't know if that'll help you or not, but if you remember that, Kelvin should always be the higher temperature. Then you'll remember, oh, I need to add 273 to get to Kelvin. I need to subtract 273 to get to Celsius, okay? What's another way? Oh, maybe this will work better for you if you need another mnemonic. I'm really sorry. I'm really sorry. Totally forgot. So it's weird we were talking about Superman and I just wrote Clark Kent's initials up there. This is Celsius and this is Kelvin, right? Kelvin comes after Celsius in the alphabet. It's a higher letter than C. I don't know if that helps. Okay, so Kelvin should be a higher number than Celsius. Maybe that's helpful. Okay, so K comes after C in the alphabet, right? So it is a higher letter than C. Does that kind of make sense? Okay, so Kelvin should be a higher temperature than Celsius. So you add 273 to get to Kelvin. You subtract 273 to get back. Oh, yeah? Good job. All right, so hopefully that helps with that conversion. There's nothing over there to erase. Now let's practice a little bit on these. And then I'll turn you guys loose on a worksheet that you won't have very much time to do in class, but it's easy. Convert 293 Kelvin to degrees Celsius? Yes, we should. So 293 Kelvin to degrees Celsius. Do I need to subtract or add? Okay, good, because Kelvin is the bigger unit, right? So 293 minus, what? 273, right? You got to remember that number 273. Hey, we should be able to do this in our head. It's just Kelvin. Yep. I know that's kind of weird. Everything else has a little degrees sign, degrees Celsius, degrees Fahrenheit. It's just Kelvin, okay? I'm not going to count off if you put degrees Kelvin. It's not a big deal. So you would end up with 20 degrees Celsius, right? Now, why did I put the point there? This needs to be exact to the ones place because both of these are exact to the ones place, right? 293 minus 273. Remember, when you're doing subtraction, you just pay attention to place, right? 3 minus 3 is 0, 9 minus 7 is 2, and then that's obviously 0, right? So we need to be significant to this place, so that's why I put the decimal point, okay? And then the last one on here, 23 degrees Celsius to Kelvin. Well, that probably goes the other way, right? So we're going from the smaller unit to the bigger one, so we're going to add 273. And that's going to give us 296. And you don't have to put the decimal point if it's not a 0. You can if you want to. That's fine. 296 Kelvin. Again, with the circling and boxing. I don't know. Okay. Does that make sense? That's not too hard, right? Okay, I'm going to give you guys a worksheet. We'll have a little quiz on temperature stuff tomorrow, and then we're going to start a lab. Okay? All right, that's it.